Okay, we're going to do another example with the method of false position. So we have some problem. Let's say we know that 1/2 of x squared plus 1/3 of x squared happens to equal 3,000. We want to solve this. So I'm just going to pick a number. I'm going to pick something easy for me. I want it to be divisible by 2. I want it to be divisible by 3. Let's just say, I'm going to guess x equals 30. And of course, that's my guess. Okay, so let's see what happens if I plug 30 in. I get 1/2 of, well, 900 plus 1/3 of 900, so that's 450 plus 300, 4, 5, 6, 750, which once again, that's the wrong answer. That's no problem with the method of false position. Now there is going to be one catch. We're dealing with squares. So normally what we would do is we would take our answer. How would we get 750 to turn into 3,000? Well, we divide by 750 and then multiply by 3,000. So, well, 300 divided by 75 is 4. So that's what we would multiply by in order to turn our x squared into the right answer. But we're looking for x. So since I know, hey, I need to multiply by 4 in order to turn x squared into our right answer, what I have to do is I have to take the square root of 4, which is 2. So basically I multiply my original answer by 2. So I get 30 times 2 equals 60. And 60 equals x is the correct answer. So the only difference between using the method of false position for x and x squared is at the end, when I get my number, I take the square root. If I was using the method of false position for x cubed, in the end, when I take my answer, I would take the cube root, and so on and so forth. So as long as you keep that in mind, you'll be okay. Keep in mind that this method of false position doesn't work for when you have x's and x squareds and x cubes. It's a very simple method for when the unknowns are all the same. They can all be x's, they can all be x squareds, they can all be x cubes, but they do have to match in order for this to work. Otherwise, you're dealing with something much more complicated, which is arbitrary solutions to polynomial equations, which is something that fueled the development of algebra. Well, something that we're going to be getting on to much later in the course.